everyone. Our project title is Paper and Plastic Hybrid EAS RF Tag with Inkjet Printed BOM Memory. Our project advisor is Henrik Anderson and group member is Alishan, me, and Sam, Masood and Wakasan. Now here what is our goal of the project. The goal of the project is to design, manufacturing and implementation of the BOM memory on the RF tag with the sensor, and that sensor can be sense the wetness event which can be detected by the EAS anti-theft system. What is EAS? Electronic Article Surveillance System. Here is a little background. It has been tried before to print whole RF tag on the photo paper with ANP silver ink, but the problem is that the large inductor resistance made it very difficult to do working and make it very hard to do working. So ANP is a silver ink which we are using to print our BOM by using diametric printer. In standard tags, 60 micrometer bulk aluminum is used for the inductor, while printing thickness is a 700 nanometer. So we have to print 80 layers to achieve 1 ohm inductor for the same inductance. In our ink, ANP silver ink, it has nanoparticles and they does not work fully. We move next slide. Here is introduction, and I will explain the features of the BOM memory. Feature of the BOM memory can remember the wetness event, and it can store the data in the form of resistance. This resistance we use in our project to make the wetness RF tag. Now we are going to design, in the next step, we are going to design hybrid RF tag, and it will take two types of layers. First layer is photo paper printed with silver ink of BOM, and the other layer is each aluminium for foil. And here is also I will introduce coupling of the layer will be achieved by capacitor coupling. We make two capacitors and join like a sandwich by using the Alpha or other material. Here I explained before the two layers, printed photo paper and each aluminum foil, and here is the little comparison. If printed photo paper, it will have BOM connecting lines one side of each capacitor, and at the side of each aluminum foil it has coil, one side of coupling capacitor, one full capacitor. So here is the task of our project. First of all, our task is to design of the hybrid tag, which I explained before. After that, our next step was simulation of the component values, and we done simulation in the model theme. Here is a BOM programming with water having achieved bigger bandwidth. Then design the coil of aluminum foil, design hybrid capacitor, and teaching for the aluminum foils. And every step will be explained by next fellow. So here is the circuit diagram. This circuit diagram we have made in the model scene. This is our circuit diagram which we use in the project. And this circuit diagram is for the standard tag, and this is for our tag. Both circuit diagrams are look like. Only difference between the capacitors. These are the coupling capacitors, and if we are going to simplify, then we will get this one. How we can simplify? Firstly, we take, if we assume here is a BOM memory, we assume at this time it is 1 ohm. If it is high resistance, so it will, this part will be open, and the effect of the two coupling capacitor will be negligible, and only this capacitor, and at this stage we got the resonant frequency, which I will explain in next slide. If it has zero resistance, it means it will behave like short, and it affect on here, and these are parallel, and then we take series combination with this, or then we can solve this circuit diagram. Here is the layout of our final tag, RF tag. Here you can see here the capacitors. These are two coupling capacitors, and in this tag the black two boxes shows our coupling capacitor, and this capacitor is that capacitor, and the warm memory we make here warm memory, and the black part is the aluminum foil, and the red part shows the printed side. Now in this design, by sliding the paper side up and down, values of the capacitor can be adjusted by controlling the connecting area. This is our final tag, as I told you. So I move next. In previous slide I showed you this circuit diagram. This is we concerned about that diagram, and when we run into the, because why we make this simulation, because before making the tag we want to check our results in the simulation part. That's why we make in model sim, and here we get the results. If I explained that before, that if it is short means the coupling capacitor also affect in the circuit, and it will be resonate at this frequency 8.3 megahertz, and this line shows that value, and when if it will be very high, then it will be open, and only this part is the circuit, and this line shows for that, and this the resonant frequency. Resonant frequency means that the tag will be triggered at that frequency, and the frequency of this one is 11.8 megahertz. So this is our result of the simulation part, and for further slide will be explained by next fellow, Sam.
Okay. I'll be talking about the EAS working system. From the picture, we have seen how it's been structured, the standard one, and the EAS system is a kind of system that is used in shops or library where there are merchandise or books that are supposed to be protected, and the main function is that it is supposed to function as an anti-theft system, whereby any article that has not been deactivated cannot be taken out. What it does, from the diagram we have seen the component contains a transmitter and a receiver, and any article that is being brought closer or that is about to be taken away that has not been deactivated, it sends a signal, and this signal is being transmitted to the receiver, and this is kind of bring about an alarm, whereby it's being known that something is happening here. From what is being written, the EAS system produces an electromagnetic energy around where it is. It creates an electromagnetic zone. When you are approaching it, that's when it triggers the alarm. And